Alright, so in this lesson, we're going to look at the perimeter and area of triangles and how we can use that and apply that to the same concepts that we've been talking about. So identifying types of triangles, as well as using perimeter to help find area or vice versa, and setting up and solving equations with these concepts as well. So first, just a quick review on area of a triangle. So to find the area of a triangle, we've got the formula 1/2 base times height. So we just do the base of the triangle times the height of the triangle and then half of that. That's our formula. Now, before we do that, we do need to understand something about the base and height of a triangle. The base and the height of a triangle are always perpendicular. All right, so the base and height always form a 90-degree angle. That's the definition of perpendicular. So if we're looking at this triangle over here, let's say that we know this is a right triangle. That's why identifying triangles is important to do this. So if we knew that that angle was a right angle, then our base and height would be 3 and 4. So we could just do 3 times 4, 12, but we need half of that, so the area would be 6 square units of whatever the units for this triangle are. So let me clean that up a little bit. It's kind of turned into a mess. This area would be 6. Again, 3 times 4, and then half of that is 6. In this example, none of these sides are right angles. So we'll say that this is an acute triangle. All of these are acute angles. So the base and the height are not actually going to be two sides of the triangle. One of them will be a side of the triangle, but the other will be a line that is perpendicular to the base. So if we said that 9 was our base, then our height in this case is actually 5. So to find the area would be 9 times 5, which is 45, and then half of that, which is 22.5. So the area here, we're using a line that's not actually a side of the triangle, but it's perpendicular to the base. So, and it goes from the base to the top of the triangle. In this example over here, here's our, we could call this the base. This is perpendicular and it goes to the top of the triangle. So we're always looking for the base and height, and it needs to be perpendicular. So for this one, we're going to find the area using the perimeter. So perimeter, quick review, perimeter is just the sum of all the sides. So if we add these three expressions together, 5x minus 2 plus 6x minus 2 plus 4x plus 1, we would get 27. So to simplify this a little bit, we're going to combine the like terms, 5x, 6x, and 4x. So 5 plus 6 plus 4 is 15. So 15x. Go ahead and combine the constants as well. So negative 2, and 1. Negative 2 minus 2 is negative 4, plus 1 is negative 3. And again, that equals the perimeter, 27. So we can actually find x, and using x we'll be able to find some more information to help us find the area here. So add 3, 15x equals 30. If we divide by 15 to get rid of that 15, we find that x equals 2. Now, again, this isn't the area, but this is just x. But what this will do is allow us to actually find the dimensions of this triangle. And for the purpose of this question, we'll assume that this is a right triangle. That'll be important later for the same reason we just discussed. So we plug 2 in here. 4 times 2 is 8, plus 1, this is 9. 5 times 2 is 10, minus 2. This is 8. So we have 9, 8, 6 times 2 is 12, minus 2 is 10. Okay, so now we actually have the dimensions of this triangle. To find the area, we use that same formula as before, 1/2 base times height. Well, where's our right angle? Right here. So our base and height are the 9 and the 8. So plugging it into that formula, we would just do 1/2 of 9 times 8. So we can do 9 times 8 first. 9 times 8 is 72. And then half of that is 36. So the area of this triangle is 36 square units. So that is the area of the triangle. And so again, this video was just kind of a review on what area is, what perimeter is, and one of the ways in which we're going to be using this concept.